We are getting close to being finished, but let's see, we have about 10 minutes left. So let's look at the difference between a true experiment and a quasi-experiment. In a true experiment, the investigator randomly assigns, notice how that's in blue, randomly assigns participants to the different levels of the independent variable. And when an experimenter does that, we refer to that independent variable as a true independent variable. So in order to be a true independent variable, it has to be the case that it's at least possible for the experimenter to randomly assign people to the different levels or conditions. In a quasi-experiment, the investigator cannot, it's theoretically impossible, the investigator cannot randomly assign participants to the different levels, and that makes the independent variable, we can call it one of two things. Some people call it a subject variable, a subject independent variable, and other people call it a classification independent variable. Either way, either term is okay. You can use subject or classification. Now, again, the key is it theoretically possible that the experimenter can randomly decide where people go, or is it theoretically impossible? So let's go through some examples. Participant sex. Let's say I'm the investigator, I'm the experimenter. Can I randomly assign you to be male or female? Well, my surgical skills are not that good, so the answer is no. It's predetermined, right? You come to the experimenter with a genetic sex. All right, so you're genetically male, genetically female. Now, there are some genetic, we refer to them as mutations. I don't want people to misconstrue that term as being negative. It just means that it is outside of what normally happens in nature, where an organism is defined as either XX or XY. All right, but so let's just stick with XX, XY, right? I cannot randomly assign you to a genetic XX or a genetic XY. It's predetermined, right? So that would make participant sex a subject or classification IV. You come in with in a pre-existing level. Like it's a variable that's already existing that assigns you to a specific level. What about SES? Again, I cannot randomly, not easily anyways, randomly assign you to a specific social economic status. That is predetermined. When you come into the testing environment, I'm going to ask you a bunch of questions, and based on your answer, I'm going to say, okay, so you belong in the high SES group, or the medium or the low. It's predetermined, so that's a subject or classification IV. Same thing with natural eye color. Okay, if your natural eye color is blue, that's pre-existing. I can't randomly assign you to be blue. All right, if the way I define eye color is natural eye color, I can't randomly assign you to a blue-eyed group if your eye color is brown. Right? So it's a subject or classification. Now, we do have ways that we can randomly assign people to eye color. Not natural eye color, but just eye color. So you can get colored contact lenses, and I can randomly assign you to the red-eyed group, the blue-eyed group, the green-eyed group, the multicolored group by giving you different colored lenses to put in your eyes. And in that case, then that would be a true independent variable because I can randomly assign you to an eye color group. I just can't randomly assign you to a natural eye color group. So if you have an independent variable, and that independent variable, the different levels, are based on some sort of pre-existing condition, In other words, you have a subject or a classification independent variable. That means you're doing a quasi experiment, right? So your independent variable is classification or subject. Let me run through an example, and this is one that's in the book. So it started because I was vacationing in California, and I came across this couple, and they were feeding the seagull fries and stuff from their lunch. And I was wondering whether seagulls that hang out on the beaches have more cholesterol in their blood than seagulls that are found on some deserted island in the middle of the ocean where there are no French fries and hamburgers and stuff like that, right? So we might want to do an experiment to see if these beach birds are somehow different in their cholesterol levels from the island birds being the ones that have a natural diet. So here, I'm defining the independent variable as something very, very specific, diet type. I could say beach versus island, but really what I'm studying is the Western diet of French fries and hamburgers and all that nice stuff versus a diet that birds would normally eat if they were on an island. Oh, my 5-minute warning. Okay, so we've got fast food versus normal diet. Now, I can't take a bunch of birds, a bunch of seagulls, and randomly assign them and say, okay, I want you to go live on this island, and you birds here are going to live on the beach. I couldn't do an experiment like that. I could do an experiment where I have birds that are born in a lab and housed in cages. In one group, they get their natural diet. In the other group, they get their French fries and hamburger diet. I could do it that way, in which case it would be a true experiment because I could randomly assign them to the healthy diet and the unhealthy diet. But I'd have to keep them in cages, etc. But I want to do a more natural type of experiment. So I'm going to look at the birds that are predefined as the healthy diet by studying them out on a deserted island. And the other type of birds, they're predefined because these are birds that hang out on the beach all the time and get the fast food. Now, there's some control in this type of design because I'm going to make sure I study, let's say, 100 of the beach birds and 100 of the island birds, and I'm going to try and get the same age of bird, etc. But the way that they've been placed in the groups, the different diet types, is not random. So it makes it a quasi-experiment. The dependent variable is cholesterol levels. Again, there's some control because I'm going to make sure I have 100 of each type of bird. And I didn't put it here on the slide, but I'm also going to make sure that I have, about the same age of birds. And if, I'm going to make sure that at least through outward appearance, they look to be relatively healthy. Okay, but this is a quasi-experiment because I am comparing two groups where I have not randomly assigned them to the different groups. So it makes it a classification or subject independent variable. And, it also means that there could be many ways in which these two groups are different besides their diet. All right, so that's a pitfall of a quasi-experiment. With a quasi-experiment, there's almost guaranteed to be lots of confounds. So for example, the birds that are living on the island, they probably differ in a lot of ways. Maybe outward appearance-wise, they look to be equal in their health, but the island birds probably have less exposure to environmental toxins. So maybe they're going to be different in ways beyond just the diet. And that's going to have an impact on their cholesterol levels. Maybe they're more social with other birds. and that can have an effect on their cholesterol levels, right? Beach birds, what do? They compete for those French fries. Have you ever seen two gulls going for the same fry? I mean, it's kind of nasty, right? So there's all these other confounds that could exist in a quasi experiment. In a controlled experiment where we keep the diet as a true independent variable, where we randomly assign the birds to a diet type, keep them in cages so we control all the other variables, well, then we're much less likely to have confounds. And I think we're going to have to stop, and this is actually a good place to stop. We're going to talk about descriptive research and more than likely finish up all of chapter 1 in the next lecture. All right, so stay tuned, and I will see you next time.